Okay, guys, this is the midterm, so let's go over these really quick. Okay, here they want you to basically state whether it's true or false. So here the first question, they're asking you the expected value of a random variable can be thought of as a long run average. That's true, right? That's true. That's the reason it's called expected, right? You expect, right? In the long run, you expect that the value will approach that value, right? That's the reason it's called expected value. Which basically is the mean, right? So the number of courses a student is taking this semester is an example of continuous random variable. No, right? Because the number of courses is countable, right? You can take one course, you can take 2, 3, 4, 5, 6, and 7, and so on, right? In theory, it's infinitely countable, right? It means you can go forever, right? But it's countable. I mean, you can count it, right? Basically, continuous means something is between some interval and between, let's say, like I was giving you in class the example of the cows. Remember, like one cow can range, I mean, the weight can range from 30 kilograms to, say, 500 kilograms, let's say, right? So that the range between 30 and 500 can be any weight. It can be, I don't know, like, let's say 50.112. So it can be, decimals are involved, basically, right? So here, the number of courses is not, so this is false, right? And I just explained to you why. When the binomial distribution is used, the outcomes must be dependent. No, the outcomes must be independent, right? In order to be true. So this is false, right? So those are the basically the assumptions for the binomial distribution. But the binomial experiment has a fixed number of trials. Yes, that's true. Has a fixed number of trials. Again, that's in the assumptions that it's on your slides. The total area under the normal distribution is infinite. No, that's not true. The total area under the normal distribution is always 1, right? It's always 1. Okay? So this is false. The standard normal distribution is a continuous distribution. Absolutely true. Right? Because it's it goes from, it's continuous because it can take any value, right? It can be decimal, it can be any value. All variables that are approximately normally distributed can be transformed to standard normal variables. Absolutely, right? That's the whole point of that's the reason we use the C table, right, to find the probabilities, right? Or vice versa, we can look at the probabilities to find the C score, right? So if we're looking for a particular value, right? So in this case, all variables are approximately normal distributed can be transformed to a standard normal variable. Absolutely true, right? This is true. The C value corresponding to a number below the mean is always negative. Yes, right? Because the mean is right in the middle of the distribution, right? So that always takes a value of 0, and below the mean, which is 0 in the standard normal distribution, then you have -1, -2, -3 to the left, right? And that implies that that's a negative 1 standard deviation below the mean. -2 implies that's 2 standard deviations below the mean, and -3 implies that's 3 standard deviations below the mean, right? So the C value corresponding to a number below the mean is always negative. Yes, that's true. The area under the standard normal distribution to the left of C the area under the standard normal distribution to the left of C is negative. That's false, right? Because we know by definition that the probability is always between 0 and 1. You know that, right? So the probability is defined as a function, right? And we know that that function can take values between 0 and 1. The area cannot be negative, right? Okay, especially probabilities. Probabilities, you know that area, it's a probabilities, area probability, right? So it cannot be negative, right? So that's false. The central limit theorem applies to means of samples selected for different populations. That's false, right? So if we're talking about one population, right? Let's say this is the population that we're talking about. We can take infinite samples, right? Let's call this is X1, X2, X3, but all these samples, they must have, or they must come from the same population, right? It cannot come from a different population. Let's call population 2. I cannot say that X5 is the sample. It's the, I mean, the central limit theorem applies to the means of samples selected from different populations. No, it has to come from the same population, right? Regardless, its shape, right? It can be symmetrical, right skew, left skew, but at the end of the day, the mean of the sampling distribution or the distribution of the sampling distribution must be normal, right? Regardless of its shape and of the original distribution, let's say, right? So here we said that this is what? This is false. Okay, has to come from the same population. Now, here in this part, they're asking you calls for fire company, right? The number of fire calls from this fire company receives per day. This is basically its distribution, right? And as we can see, number, we have a probability distribution here, but this is a discrete probability distribution. How do I know that? Because these numbers are countable, right? That's the calls for a fire company, the number of fire calls. So these, you can receive 5 calls, 6 calls, 7 calls, 8 calls, and so on and so on and so on. So in this case, they're only asking you to graph it, right? So you know, this will be your the random variable x will take numbers, in this case 5, 6, 7, and 8, and the frequency, right? Well, in this case, they define it as p of x, the probability, right? It's 0.28, 0.32, right? Let me fix this a little. Let me make it a little bit bigger for you guys. Or maybe here, maybe that works. Okay, 0.32. Let me move this around. 0.32, 0.09. Have enough space, but you know, you get the point. They just want you to graph the frequency. So let me draw this here. They're better. Let me draw a little better. So here is 0.28. Here is 0.32. Here is 0.09. 0.21. I should start here, right? Let me do it in order so it kind of makes sense. 0.09, so we did this, right? We have 0.10, it's gonna go in order. 0.21, then we have 0.28, and then we have 0.32, okay? So I think that will be easy. So this is, oh, sorry. Well, I could do it the other way too, but let's do it in an easy way for you. So 5 goes here, 6 goes here, 7 goes here, 8 goes here, 9 goes here. And we said that the first one was 0.09. And then we got 0.10. And then these are the probabilities, right? So that's your frequency. Sometimes they describe that as P of X or F of X, depending on the notation that they're using. So we have 0.9, 0.10, 0.21, 0.28, and then this is 0.31, right? So they want you to basically draw or graph the PMF, right? So here we have 5 is 0.28, so that's here, right? And remember, it's just like this, right? Because this is Greek. And you have 6 is 0.32, that should be around here. And then the next one is 7 is 0.09. It's about here. And then 8 is 0.21, maybe around here. And the other one is 0.10, maybe about here. And that's it. That's the only thing you need to do, right? They just want you to graph it down. Here, they're asking you call for a crisis hotline. The number of calls received per day at a crisis hotline is distributed as follows, right? So they give you the PMF again. How do I know it's PMF? Because this is countable, right? 30, 31, 32, number of calls, right? and they give you the respective probabilities, right? So the only thing you need to calculate here is the mean, right? The expectation, right? So the expectation is the sum, the sum I goes to 1 till n, x sub I times the probability of x sub I, or you can define it as f of x sub I, depending on the notation that they're using here. So I'm gonna use p x sub I because here they use p, and this implies that this is the sum. I goes to where? Well, this case, it goes to 30 to 34, right? Or you can say, because I is a subscript, actually you should go from 0 to 4, right? And then it will imply that this is x sub 0, right? This is x sub 1, x sub 2, x sub 3, and x sub 4. That's the subscript, right? So meaning this is basically x sub 0 times the probability of x sub 0 plus that's what that means, right? So this means this, right? And then this is x sub 1 times the probability of x sub 1 plus x sub 2 times the probability of x sub 2 plus x sub 3 times the probability of x sub 3. And you have 1, 2, 3, 4, 1, 2, 3, 4, and you need one more. X sub 4 times the probability of x sub 4, right? So if you do that by hand, kind of takes some time. You don't need to do that by hand. You can use a calculator. So we use a calculator, we do this, right? For the expectation. You need to find, let me show you really quick. Let me see if I can share this with you. 1 second. 1 second. Okay, so you should be able to see my screen right now. And we need to calculate the expectation. Let me make this bigger. What is that? Here. So what I need to do is I need to go to stats, input my data, right? Very easy. Input my data, so I have 30, 31, 32, 33, 34. And then on the other side, I need to type the respective probabilities, right? So 0.05. And then we have 0.21. Sorry about this. 1 second. 0.05, 0.21. And then the other one is 0.38. And then 0.25. And then the other one is 0.11. Once you're done with that, you go to stats, you go here, but instead of leaving just the frequency, this is the L1, that's the table that you input basically the values of the random variable, which it was 30, 31, 32, 33, and 34. Now here in the frequency, you have to put the respective probability. So you're gonna put second, L2, enter, and that X value should be the expectation. Okay, so that's the expected value. So when they're asking you for the mean here, that's the expected value, right? So the mean is the expected value is 32.16. Let's double check if I type these values correctly. So we get 30, 31, 32, 33, 34, and the probabilities are 0.05, 0.21, 0.88, 0.25, 0.11. I went to stats, calculation here. So I put L1 is the table. So the values that the random variable can take, again, 30, 31, 32, 33, and 34. And L2 is the probabilities, right? So if you press enter, you should get 32.16 for the expected value, and you need to calculate the variance. The variance, here you need to calculate it. Standard deviation is given here, right? So the standard deviation here is 1.03, right? You can round it to 104 if you want, right? That's not a big deal. And the variance, you just need to square that value, right? So I'm gonna keep 0.365, and then after that I will square that. So find the variance, it will be 1.0365 squared. If this is squared, and you get 1.0743. And we have the expected value, the mean, and the variance, right? So that's it. Now, so let me go back to the slide. 1 second. Okay, so that was it, right? So I'm gonna record 2 parts. This is the question 4, so that means I need to do 1 more because there's 10 questions, right? And yeah, let me finish this part first, and then I will do the other part after. So employ, here they're asking you employ woman. I think that's the title, employ woman, right? So here they're asking you if 60% of all women are employed outside the home, find the probability that in a sample of 20 women, exactly 15 are employed, right? So you have to do part 1, part 2. So this is a binomial distribution. How do I know that? The probability is fixed. They have a fixed number of trials. There's 2 outcomes, success or failure, and the outcomes are independent from trial to trial, meaning that if 15 are employed, the probability of 15 employed does not rely on the probability that 16 will be employed, right? So they're independent, right? Basically, right? So they're not relying on the previous result, basically, if you want to put it that way, right? So now what I need to do is I need to set my my values, right? So here I have 60%, so this is 0.60. This is probability of success. Failure will be 0.40, and the sample size is 20, right? And the first question is, what is the probability that exactly 15, right? So here I have to use the calculator, but in reality, you have to remember your PMF. So f of x equals the probability of x takes on x, which is n choose x times the probability of x q n minus x. This is the PMF of that of this distribution, right? So this discrete probability distribution. So now we just need to replace the values, right? 15, a random variable x takes on 15, the sample size is 20, 15, probability of success is 0.60, x is, what is x here? 15, q is 0.40, n minus x is 5, right? 20 minus 15 is 5. So this is calculator, right? So you can do this with a calculator like I showed you in class. So you know what are the probabilities here. Let's go to the calculator to do this really fast. So here I go stats, I'm sorry, second stats, and I go to binomial PDF. So what is the trials? We know that it's 20. The probability of success is 0.60. X value is what? X value here is 15. And that's it, right? So that's it. That's a probability, 0.0746, right? Or 7%, 7.5%, right? So you can round if you want. That's fine, as long as the value doesn't differ too much. That's fine, right? So that's the answer. So let me go back to the slide. So this is what you're supposed to have, right? This value. Okay, so this is what you're supposed to have. Okay, so that's the first thing you have to do. Now the second is asking you at least 10. At least 10 means 10 or more, right? So this is kind of tough, right? Because here you have this big situation, right? At least 10 implies that I will have to keep adding the probability of equals 10 plus the probability of x equals 11 plus the probability of x equals 12. And if I do 1 minus the probability of x is less than 10, right, which is the complement of that, I still have to do a lot of calculation, right? I have to do the probability of x equals 1, the probability, I mean, x equals 0, x equals 1, x equals 2, x equals 3. That might take some time, right? So I can do here the binomial approximation that I taught in class, right? I'm gonna leave that up to you, because if I do that, that's gonna take some time. But I can do that in a different video, because if I do that right now, it's gonna take forever. So I'm gonna do that. I'm gonna keep this one. I'm gonna highlight it. I'm gonna do it for in just like that problem by itself, okay? Because that's gonna take some time. And here, but anyway, how you will set up this problem will be like this, at least 10, right? So at least 10 will be like this. I will do that problem in a little bit when I finish these questions. So at most 5. So at most 5 means this, at most 5. So that's what implies at most 5. But you have to be very careful here, because here they're not asking you, we're talking about before employ, right? Here they said not employ. So your probability of success will change. So let me change that so you don't get confused. So the probability of success right now is 0.40, and the probability of failure will be 0.60, right? And everything else after that is the same. Why? Because they're asking you here about the probability that I'm not employed. So your success will be the ones that they're not employed, and your failure will be the ones that they employ. You have to be careful with these problems, okay? So now, so 5 implies what? 1 minus the probability of x will be, here it would be easier for me to do, not use a complement, but because a complement will be implied that will be greater than 5, right? Or 1 minus probability of x greater than 5. And that's not feasible, right? So in this case, I will keep it like this. So this is the probability of x equals 0 plus x equals 1. This one, with this one, you can still do the binomial distribution, right? X equals 2, x equals 3, right? X equals 4, and x equals to 5, right? Okay, so you can just plug these values in the calculator, right? So let's do this really quick. This is not a big deal because we have a calculator, so it's not that difficult. So here, I should not erase that. Okay, so stats, you go to calculate, I mean, actually second bars, and you go to binomial PDF right here, and we know it's 20, but the probability of success will change to 0.40 this time, and we have 15, x is 0 this time, right? Because we have to start from 0 to 5. So if we do that, so we get some very small value, right? Kind of almost close to 0, right? That's very little, right? So I'm gonna say 0. I'm gonna put 3 times 10 to the 3.6, 3.6 times 10, or 3.7, 3.7 times 10 to the 10 to the negative 5. That's a small value. That's not significant too much, but I'm just gonna add it at the end. So now after that you put second, enter, and instead of 0, now you put 1, right? And you get the answer, right? So that's also a little value. So this is 4.9 times 10 to the negative 4, and then you change to, now this time you change to 2, because that was to 1, right? So now you put 2, and you should get 0.003 or 0. Let's round to 4 decimal places. So 0.31, and then you do again, second, and you put 3 this time. This is 0.0123, and then you put 4, second, this time you put 4, 0.0350, and then the last one, 5, right? 5, and you get 0.0746. Now you need to add these values, right? So let's add these values. The first one, the very first one. Let me see what it was. The first one, it was 3, this one, right? Okay, so let's add that, plus, let's use the second one. So this is the first one, the second one is this guy. And then plus the third one, third one is this one, plus the fourth one, the fourth one is this one, plus the fifth one should be this one right here, plus the last one. And then you put equal, and that's the probability. So 0.1256, right? So that's the answer. That's it. So let me go back to the slide. So this is what you're supposed to have, right? This one, we have to use the binomial approximation, right? Or you can do this, but this is kind of, I mean, you can do it if you want to avoid the binomial approximation, but it's more elegant to do the binomial approximation in this case, right? If you do this like from 0 to 10, I mean, that's okay, but it's okay. I don't know, whatever is easier for you. Okay. And I'm going to stop here because I want to share this with you as soon as possible, and then I'm going to record the other part, okay? I'll see you in a bit. Okay.